a triangle with side lengths of 4, 7, and 9. I know what they're testing here, and what they're testing is this basic rule where if we have 3 side lengths, the rule is this: we can never have one side length that is smaller than the difference of 2 of the other side lengths. Okay, so what does that mean? So one example of that is if I had a triangle that had a side length of 9, a side length of 7, and a side length of 1. This cannot exist because 1 is smaller than the difference of these 2. Now, yes, 7 is also smaller than the difference of 9 and 1. 9 is not smaller than the difference of 7 and 1, but we just need to find one instance where we have that violation and the triangle can't exist. The other rule is, let's say I have 3, 5, and 12. The other rule, which is kind of the same, is one side cannot be more than the sum of the other 2 sides. So 3 plus 5 is 8. This is bigger than 8. This triangle cannot exist. So I can already tell you 4, 7, and 9 is going to exist, but this is going to be a visual way to do it. So what we're going to show is if we kind of reach these together, we're going to be able to form a nice triangle like this. All right. So now we've created a triangle there, and that's cool. This one, again, it doesn't violate the rule, right? 4 minus 3 is 1. This is bigger than that difference. There's no combination where that will be a problem. Hey, we can make a triangle. Cool. I think that's all you have to do. All right, cool. This is not going to work, right? Because 9 minus 6 is 3. 3 is greater than 2. But you can try and see this will never reach, right? That's what that theorem shows, that we'll never be able to do this, so no triangle possible. Same thing here. 7 minus 3 is 4. That's greater than 3. No triangle possible. They don't reach. Last one. This will definitely work. And then this guy will not work, right? 2 and 3, they will never touch. So no triangle.